Hello everybody out there in YouTube land. Good times for all here, or Zachary Zabala if you prefer. We are at work again, and I did a little bit something different this time. I measured that. It's an 11-inch piece of paper. I made a mark every inch. You have two lids here. One the circle at the bottom, one the circle at the top. And I was wrong about my measurement last time. It was not 170 yards. It was actually 160 yards down to that other end. Like an idiot, I took people's words for it. So I measured it this time myself. And from the lids here to the farthest marking that I take a picture from, it will be 153.3 yards away. I did that by 20 feet increments. I will be taking a picture every 20 feet. So tomorrow I'm hoping to get the exact height of what the Sears Tower should be, the Willis Tower, from this distance at this, to scale perspective. And we're going to see how much of the bottom gets taken off. But today we're just doing a little preliminary, and we're going to see what happens. So every 20 feet, I should be taking 23 pictures, I believe. And then at the end, I'll do one from eye height, which is roughly about 5.5. I'm going to have to get a tape measure out and see that one. But that probably won't be today. That'll be tomorrow. But yeah, I hope you all enjoy this. We're going to see what happens. Oh, and I also wanted to mention one other thing. See all these lights here? They're all the same height. You see them down there? All those lights, they're not getting any lower. It's all about perspective, people. It looks like these lights are going down, 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 down. And then they set over those, Nothing is setting, it stays the same height. It's all about perspective. And then once you get so low to the ground and so far away, you'll see what happens. So I hope you enjoy this. This is experiment number 2 with diffraction. And I'll see you all down here at the other end. All right, folks. I'd have to say all in all, this experiment went pretty well. I'm not going to take too much time on each picture. Not until around 200 feet from 1.5 inches off the ground do you really start to see some good distortion. I mean, you can see it earlier, about 100 feet, you can start to see it. If I would take that blue line out of there, it's very slight minimum. It was a warmer day on this day. I'm learning. I've done a couple experiments on this since this one, and I was able to actually see more than this one showed. So I believe diffraction is caused by the amount of humidity also in the air. The more moisture and humidity in the air, the more it has to look through and the more the objects get distorted. And of course there's more humidity near the bottom, as the heavier water molecules and whatnot would be sinking. It's really interesting, folks, how all this works, how our eyes work. As you can see, the bottom is getting harder and harder to make out now, and they're starting to actually converge, the two circles from the mirroring effect. The mirrored one on the bottom is actually starting to combine with the actual image. So this is what we see why the bottom of buildings are always missing from long distances. It has nothing to do with the curve of the earth. It is never the actual amount that should be missing, and it's usually very far from it. So I mean, this is just how our eyes work. The bottom of things do disappear over distance. And then as you watch, here in a second, I'm going to go to eye level. There's about 3.5, 4 inches they're distorted. Then I go back up to eye level right here, and boom, you can see the whole thing again. So all those people saying that, oh, it doesn't matter how high you are, if on a flat plane you can't see more, blah, 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 they're wrong. Flat out wrong. So this is Good Times for All, everybody, signing out. As always, thanks for watching.